Okay. So what's the easy problem, right? Right? We go through this, and it's like, okay, what's the integral of 2x? X squared. Integral of 1, x. Put a plus c, and we're done. And we know it's right, because if I take the derivative of this, I get that. If I take the derivative of this, I get that. Everybody okay? Well, what happens if I take the integral of 2x plus 1 squared? What do? You got to multiply it out, because the only thing you know how to do is integrate term by term, and you're like, well, fine, I can do that. I can multiply this out, so that gives me 4x squared plus 4x plus 1. Take the integral of that, so we end up with 4x cubed over 3 plus, I think that's 2x squared plus x plus c. Is everybody okay with that? You don't have to do it. Right? I mean, I've already made you do a bunch of these. Right? Everybody okay? And I go, all right, well, fine. Well, what if I make this to the third? What do? You multiply it out, but you're a little more annoyed, right? I said, really? I got to multiply that out? And then I just get crazy. I said, no, I don't want to the third. I want to the 13th power. At which point, if I say take the integral of this, you go, no. Right? Because that's not reasonable, right? To multiply out to the 13th power would take up the entire board, right? So there has to be a better way. And today we're going to talk about the better way. Got it? All right? So what we do, and so actually I do want to, if you haven't written everything down, I do want you to write this part down. And so here's how I want you to think about this. Your goal in an integral is you're trying to think of something here that when you take the derivative, you get this. That's always your goal, right? And when you look at this, can everybody see this is stuff to the 13th power? Right? Is that easy? Right? And so what I want you to put down, what I want you to think of, if you see stuff to the 13th power, what has to go here so that the derivative is going to give me stuff to the 13th power? Stuff to the 14th power. Does that make sense? Mm-hmm. And so what we're going to do is we're going to write down 2x plus 1 to the 14th. So I want everybody to do that right now. All right, fine. So now, if the goal is the derivative of this has got to equal this, take the derivative of this. Okay? So off to the right, let's take the derivative. Of course, you have to remember chain rule, right? So we take the derivative, and what do we get? 14 times 2x plus 1 to the 13th times 2. Is everybody okay? The derivative of this is this guy? Now you have to ask a very important question. Is this? No. Is it close?
Yeah.
What do I need to do to make this look like this?
Divide by 28.
I got to divide by the 14 and the 2, so I need to divide by 28. And so I'm going to divide by 28. And whatever you do here, we're going to do here. And my claim is, if you take the derivative of this, you get this. And here's the beauty of it. Don't take my word for it, right? Actually take the derivative and make sure that when you take the derivative, you get this. Can you sort of mentally do it? Can you see if I put the 14 over here, stuff to the 13, everything cancels out so we get this, right? So, turns out this integral is equal to, let's do 2x plus 1 to the 14th over 28 plus c. Does that make sense? Right? So just going over the procedure again, right? Going over, when you have an integral, your job is to think if something goes here, so when you take the derivative, you get this. And you look at this and say, I see stuff to the 13th. So my guess is going to be stuff to the 14th. Take the derivative and then fix it. Right? So let's try it again. What if, I should have started further to the left so I didn't have to erase the whole thing. So what if I ask for the integral of the square root of 3x minus 4 All right, everybody written it down? All right. What do you see? Stuff to the what?
1/2.
Does everybody see stuff to the 1/2? Right? You look at this and you see 3x minus 4 to the 1/2. So you see stuff to the 1/2. What are we going to put here? Stuff to the what?
3/2.
Are we okay? We're going to write down stuff to the 3/2. And so I want everyone to put down stuff to the 3/2. So that gives us 3x minus 4 to the 3/2. Now take the derivative of it and see how close this matches to this. Okay. Has everybody got it? Taking the derivative? So we take the derivative, this is going to give us 3/2, 3x minus 4 to the 1/2 times 3. Okay. Is this close to this? All right. What do we need to get rid of?
4.5.
We got to get rid of the 9/2. Everybody see we got to get rid of the 9/2? So the way we get rid of that 9/2 is we're going to multiply both sides by 2/9. Everybody see how that works? So if we multiply both sides by 2/9, then that's going to give me 2/9 times 3x minus 4 to the 3/2 plus c, all right? And my claim is, if you take the derivative of this, you get this. Does this make sense? Right? A byproduct of all this is you're going to get really good at taking derivatives. Right? All right. Are we okay? So, all right, so these are kind of the basic ones. Well, what happens if it looks a little more complicated? All right, what if I give you, let's do the integral of, let's do x squared minus 3 to the 4th, and I'll put a 2x out here. Everybody write this down. Now, you're going to have to trust me on this part, and I'll have to explain a little bit later. Okay. So what looks different? What's different about this problem compared to the other ones I gave you?
Product rule.
There is no product rule. But you notice there's an x sitting outside, right?
Yeah.
You see there's a 2x sitting outside. Turns out that 2x is actually going to make our lives a whole lot easier. You don't know that yet, and that's fine, right? And basically, I'm doing some hand waving here. I want you to ignore the 2x, all right? What do you see? Use the word stuff.
Stuff to the 4th.
Does everybody see stuff to the 4th? So if everybody sees stuff to the 4th, what's going to be your guess?
Stuff to the 5th.
Stuff to the 5th, right? So your guess is stuff to the 5th, so I want you to write down x squared minus 3 to the 5th. Now take the derivative and see how close you get.
I see.
All right? Everybody take the derivative? All right? So when we take the derivative of this, we end up with, all right, 5 times x squared minus 3 to the 4th times a 2x. And when I look at this, is this close to this?
Hey, why don't you do chain rule on this one?
I did do chain rule, took the derivative.
You just left out the other two.
No, I said ignore that. All right? And so what do we need to do to this to make it look like this?
Hi.
No.
Divide by 5.
We have a 2x in here, right? You see the only problem we have is that 5? So I need to divide by 5. And my claim is, if I have x squared minus 3 to the 5th over 5 plus c, if I take the derivative of that, I will get this. That's my claim, and you don't have to believe me, right? You can do it, right? Like, when I give you an integral, you should know if it's right or wrong. There should be zero doubt. If you put something down for an integral and you go, I think it's right, it's probably wrong, right? Yes?
What if it's something we don't know how to take the derivative of?
A derivative?
What if it's something we don't know how to take the derivative of?
well, then there's no way you can take an integral,
Okay.
right? Taking an integral is way harder than taking a derivative. Right. So, does that make sense? Are we okay? All right, so we're guessing. Oh, so here's the backstory of this. This is how I've always thought of taking integrals. This is not how it's taught, right? Whenever I explained to my friends how to take an integral, this is virtually how I did it. And in college, I remember my math professor, he was teaching it the exact same way, and I kind of thought it was funny because, I mean, he's doing it exactly the same way I did it. And he called it guess and fudge, right? He called it guess, you guessed, right? And then the fudge is where you fix it. So I call it guess and fix, basically, right? And what I'm trying to get you to do, what you guys to do is see what's important. And what's important is I have stuff to the fourth, and you had that 2x off to the side, and it's like, you don't know why that needs to be there. Some of you guys have an idea now, right? But, so now let's look at another problem. Let's say I give you, let's do the integral of x cubed times the square root of 2x to the fourth plus 3. What, right, after you write it down, what do you see?
Stuff to the 1/2.
Did everybody see stuff to the 1/2? All right, we look at this and I see a 2x to the fourth plus 3 to the 1/2, all right? So what's your guess going to be?
2x to the 4th plus 3 to the 3/2.
Perfect, okay, do it. Take the derivative and then fix it. Everybody got it? So we go through and think, okay, so my guess is going to be, give us 2x to the fourth plus 3 to the 3/2. So I'm going to take the derivative of that, I get 3/2 times 2x to the fourth plus 3 1/2 times 8x cubed. And that makes it another 4. What am I off by? Everybody see we're off by 12? So I've got about this by 12, which means I divide this by 12. So this is going to give me 2x plus 3 to the 3/2 all over 12 plus c. Okay? And how certain are you if you take the derivative of this, you're going to get this?
Awesome.
Right.
Do it. You do.
Because you've constructed it that way, right? All right. If you're curious what the other way looks like, I will tell you, I will do a full example at the end of class Monday. I don't want to show you that way now because it kind of messes things up. But I will give you a preview of the people doing it that way. The official way is called U substitution. It's usually about 5 or 6 lines. So it's about 5 or 6 lines, and at the end of the problem, if I said you had to bet your life if it's right or wrong, no one would. Yes?
When you say you're off by 12, where does that come from?
The 3 times 4. See, that 2 went into the 8 4 times. And so I have this extra 12. I have this extra times 12 on this side. So to make this look like this, I got to get rid of the 3 and the 4 to get rid of the 12. All right? Next up, what if I give you the integral of x cubed over, what do I want? Oh, 1 plus x to the 4th squared. So a couple of things. There is no quotient rule. There never will be a quotient rule, right? You don't know how to handle a variable in the bottom. So how could I rewrite this so it looks like something I know how to deal with? Yes?
Whereas x cubed over 1 plus x cubed. Can you do that? Can you split it up into two parts?
No.
-2.
Rewrite this to the -2. You can't break it apart with the denominator, right? So you need to think of this as the integral of x cubed times 1 plus x to the 4th to the -2. And so now when you look at this, what do you see? Stuff to the what?
-2.
What's your guess? Stuff to the, there you go, go. Everybody got an answer? All right, so my guess is going to be 1 plus x to the 4th to the -1. And when I take the derivative of this, I get -1 times 1 plus x to the 4th to the -2 times 4x cubed. And so when I compare, what do I need to do to fix it?
Divide by -4.
Was that easy? We divide by -4. So if I divide by -4, well, now this gives me, now I don't want negative exponents in my final answer. So I end up with, -1 over 4 times 1 plus x to the 4th to the 1st power plus c. Is this, part of what I'm trying to do today is train you to see what's important. Right? Because if you, in an integral, there's some things that are more important than others. All right. Next up, oh yeah, this is kind of mean. What if I give you the integral of 1 minus 1 over x squared cubed times 1 over x cubed?
What is that, x squared or x?
That's x squared. Again, you don't have a quotient rule. You're not going to get one. Would you use negative exponents? So rewrite it with negative exponents. Does everybody see stuff cubed? Well, if everybody sees stuff cubed, what was your guess going to be?
Stuff to the 4th.
Stuff to the 4th.
What's 1 over x squared and negative exponents again?
What?
What's 1 over x squared and negative exponents again?
X to the -2.
Oh.
Sure. when did you take the, when you took the derivative, did your derivative kind of get close to this? So I think of this as 1 minus x to the negative 2 cubed. So my guess is going to be 1 minus x to the negative 2 to the fourth. When I take the derivative of that, it gives me 4, 1 minus x to the negative 2 to the third, derivative of this, which is going to give me 2x to the negative 3.
Yes.
Is this close to this?
Yes.
Yeah, I got to divide by the 8, right?
Yeah.
So I need to divide by the 8. And so when I divide by 8, all right, so now I know my answer is going to be 1 plus 1 over x squared to the fourth all over 8. Yes.
Should be minus.
Yes, I can't change the problem.
Oh, yeah, I see.
Yeah, sorry.
Okay.
Lucky guys.
Yeah, good luck.
Hey, so.
Shoot, I'll see if I can put it out in one
Hey,
note.
I'll look on one note.
Well, no, I don't, I haven't been able to distribute it to one note.
I won't be doing it.
Okay.
Right on.
Right.
Is there a chart thing that makes out everything?
Think so. All right. All right. Is this seem pretty easy? All right. All right. So here, let's do. What?
Most teachers are just like, here's everything, homework.
So normally it's 1 minus 1 over x squared. So I put 2 in negative x squared, right?
Okay. Oh wait, shoot! I erased
Right
it.
here and the negative in the x squared.
Was everybody okay with this? Kind of after the point. Okay. Well, you know, while we're at it,
Negative 2x.
Negative 2x.
Yes.
okay.
It wasn't. Because you're subtracting it. It's 1 minus x, which means that this entire term is negative. The 2 negatives cancel out when you put it together.
All right.
Say, this doesn't change sign, this.
All right. So everybody write this one down. We're not going to leave. I can't leave out trig functions.
You're negative. You're taking the derivative of
You are
the inside
actually.
term.
What?
You're trying to check me out.
Right?
So
No.
negative x to negative 2.
The derivative of that is
Stuff
Negative 2 to the power,
Stuff
or
squared.
negative 2.
No.
Why not?
You're
How
confusing.
negative x to negative 2. The derivative of that
Okay.
is possible. It's a negative on x and the other negative cancel out. You're not welcome.
All right.
Negative 2.
So has everybody written this down?
Yes.
Okay. I see sine of stuff. Can everybody look at this and see sine of stuff?
Yes.
So if you see the integral of sine stuff, what's going to be your guess? Cosine stuff. Does everybody see where I'm going to guess cosine stuff?
Yes. No.
All right. Yeah. Can we look at this and see sine stuff?
Yes.
Now, your job is you got to think of something here. What's the derivative of something is going to give me sine stuff?
Isn't the derivative
Negative.
So I don't even worry about the negative. My guess here is going to be cosine stuff.
So we're gonna fix it later down the line.
Yeah.
Why don't we just fix it now?
Why don't we just fix it now? It's obvious.
With simple examples, that's fine. But when they get more complicated, fix it all at the end. Right? To me, I think it's easier to fix it all at the end. All right. Did everybody see where my guess was cosine x squared? Now take the derivative of this and see how close we get.
Oh, it doesn't work itself out.
Oh, yeah. And so when I take the derivative, let's see, derivative of cosine is going to give me negative sine stuff times derivative of stuff. Now when I compare this to this, what am I off by?
Negative 2.
Does everybody see I'm off by negative 2? Since I'm off by negative 2, I'm going to divide this by negative 2. So when I write my answer, this is going to give me negative.
Wait, how do you know you're off by negative 2?
Well, when I compare this to this, do you see we're off by a minus sign?
Okay, yeah.
And you see we're off by a 2?
There's a 2x and the answer is the x.
And so I end up with negative cosine x squared all over 2 plus c.
I'm gonna miss points for not putting plus c on the AP exam.
Actually, no, you won't. They've got them
You
structured.
have the multiple choice.
Okay. All right.
We'll have to put plus c on an FRQ.
Wait, how do you know it's? Why is it?
Let's not, let's worry about the
Yeah,
process
yeah, yeah.
now. Okay, yes.
Why did it go to negative cosine squared? Why is it negative cosine in the answer to the negative sign?
Okay. This, so this was your guess, right?
Yep.
And then I'm trying to make sure that when I take the derivative of the guess, I get my original problem, right? I'm trying to say, whatever I put here when I take the derivative exactly equals this. But when I put this down, I take the derivative and see how close I got. So when I take the derivative of this, I get the negative, I get negative sine x squared times 2x, right? And now when I compare this to what I want, right, this doesn't exactly match up, does it? It's off by a negative and a 2.
Yeah.
So that's why I had to divide both sides by negative 2. And now my claim is, if you take the derivative of this, you will get this. Right? One more, and then we're going to practice. And let's do, what's the integral of sine x over cosine squared x dx?
Do we have to use trig identities for this?
What?
Do we have to use trig identities for this?
No.
When you have cosine, like with this squared up there, isn't it just the whole thing squared?
It means cosine of x quantity squared. Now, you don't know a quotient rule. You never will. Could we rewrite this so it doesn't look like a fraction?
Yeah, you just change that cosine squared to negative 2.
So you rewrite this as the integral of cosine x to a negative 2 sine x dx.
Isn't it also just tangent x cosine x?
Don't do that.
Okay.
Just go with me on this one, all right? All right, do you see how I did that?
Yeah, no, I got it.
What do you see?
I see stuff to a power.
Does everybody see stuff to the negative 2?
Well,
Do you see stuff to a negative 2? What's your guess going to be?
Cosine x is negative 1.
Write down stuff to the negative 1, take the derivative and see how close you get.
wait, doesn't it just equal out? If you have negative 1, is it, does it,
Well, sometimes you don't have to fix it. Sometimes you're a good guesser.
yeah,
Doesn't on this one you have to change something?
no, because doesn't the sign, the negative sign x, the negative 1 to the sign x,
So when you look at this, all right, did everybody guess cosine x to the negative 1? And when we take the derivative, let's see, we end up with negative 1 times cosine x to the negative 2 times negative. Okay.
yeah, it's just that.
All right. So wait a minute. Do I need to change anything?
No.
No.
Oh, I was good at guessing, wasn't I? So if I'm good at guessing, then you remember our goal was to put something here that the derivative exactly equals this. Done, right? Of course, I don't like negative exponents. Since I don't like negative exponents, we'd have to write this as 1 over cosine x plus c. But I'm willing to bet if this was a problem in your textbook, they wouldn't have 1 over cosine x in the back of the book. They would have secant x plus c. 'Cause
They're fancy.
Yeah, because they're fancy like that. Does this make sense? All right. So here is your homework. I'm having issues having it to distribute to OneNote. It's in your textbook. It's page 301, 5 through. Oh, good, 'cause you got 10 minutes. So we'll start work on that. 5 to 25 odd, and then 33 through 41 odd.
I think a picture of that.
Yes. Actually, let me hit stop.
That's it.